Thanks for joining us today for this discussion. And the panel we are doing is how close are telecom operators to becoming cloud native? I will quickly invite my panelists to introduce themselves. They are very famous and very well known in the industry. I've heard them quite a bit talking about cloud native. Please quickly introduce yourselves.
Good morning, everyone. So my name is Philippe Ensarguet. I'm VP Software Engineering working at Orange, and I'm currently leading the transformation for how to shift from a telco DNA to a techco DNA, and cloud native is the strong foundation of all this movement. So really excited to be part of this panel.
Okay, let me continue then. My name is Steuernagel, and I'm in Deutsche Telekom, responsible for in group technology, responsible for the cloud, and yeah, it's the NT cloud and I'm taking care of mainly, and cloud nativeness is driving me. Also personally, I'm very interested in this topic, and so I'm a little bit frustrated sometimes when I see the outcome. So we will dig into that, I guess, today.
Well, and that's me then. Good morning, everybody. My name is Frank Brockners. I work in Cisco's emerging technology group called Outshift. I'm a distinguished engineer, and I work in open source for quite a while. I'm busy in the IETF, and here I'm representing the Linux Foundation networking group. Yeah, thanks for having me.
Thank you, Frank, Philippe, and Kai. So before we, just jump into seeing how much cloud native telcos are and where telcos are in terms of this cloud native, I guess let's just clarify what this cloud native is, because sometimes people refer cloud native, sometimes you hear containerized. So what does it mean, in your organizations, for Orange, for DT? And if you can define, some of your North Stars for being cloud native, what do you want to achieve with it? Let's start it there.
Philippe.
Let's start with Philippe.
Okay,
yeah.
okay. I really love the starting point of the discussion, because it's all about definition, and we need to have those definitions to have the right expectation. I would say that the joke I'm giving a lot of time is that when we are talking about cloud native network function, the C of CNF is not for container, it's for cloud native. So joke aside, I think that we really need to clarify the cloud nativeness of what we are expecting as telecom operator. And here, basically my North Star is quite simple. I've got two very strong influence. The first one is what we did on the NGMN manifesto definition, that basically is pushing forefront decoupled infrastructure and application, API first, declarative and intent-based automation, the GitOps unified Kubernetes resource consumption, the unified Kubernetes closed-loop reconciliation, and interoperability by a well-defined certification process. So it's a pledge at high level. But if we want to go a step down further, I think that on the work that we jointly made with a few peers amongst telecom operator in the Linux Foundation Cloud Native Technology Initiative, CNTI, white paper is super important. We are talking about basically workload that need to be compatible, stateless, secure, scalable, configurable, observable, portable, parity across environment, and with a huge capability in terms of observability. So basically, when I'm talking about cloud native, it's definitively the level of expectation that I'm having.
So I cannot agree more with Philippe, and I can maybe copy all what he said, maybe emphasizing on a few points. So yeah, I'm on the same point. So I often got confronted with the statement that CNF is containerized network functions, which is definitely not. And I'm really astonished that in the industry, this is kind of surviving that long, while we all have kind of all these nice white papers, also Philippe referred to, explaining exactly what we want and what we need. But even suppliers, even other telcos, even kind of the industry seems to not understand what we are aiming for. So the understanding is, I think, in this round, yeah, I hope that we have the same understanding. I strongly believe we have the same understanding, but I've been in other rounds where we didn't. The North Star really is that we are able, from the use case, we are able to apply changes doing operations without any service degradation. So this is, yeah, and that it requires kind of independency of services and microservices and so on. We want really to easily scale in and out with the demand, with the load. Also, that is yet a dream that we can do it in the network workloads the same way as many IT workloads would work on, and it's probably easier in that world. But yeah, also we want to get there. And finally, yeah, kind of what is also driving us, we want to get to generationless network functions. So if you look at the mobile networks, and we have 3G, 4G, 5G, it made sense in the beginning to have because we bought in new equipment. But now we are changing application on top of a cloud. And why does it need to be a new generation other than for marketing reasons? So this is kind of the North Star where we really want to get from the use case perspective.
Inderpreet, if I may, what is very important in what Kai highlighted basically is that it's a shift. It's something that is new with the new expectation that we both shared. And we must keep in mind that if we look back in the mirrors, when it was the age of PNF and VNF, it was mostly all about monolith, whether they are physical or logical. And here, it was highly made in a very vertical ecosystem. So with the cloud native approach, the true, I would say, North Star is to have the ecosystem transforming itself to become much more software driven and having a software behavior as the vendor. And here we really need to be supportive by sharing the kind of requirement and the reason why, because it will require for the vendor ecosystem to give up a very lucrative professional services in terms of business model and control over vertical integration. So we must accompany, because it's a whole movement shift. We are truly expecting to have 100% software based with the full practices in terms of software to be really turned into the cloud native approach.
And maybe allow me to zoom out or add a little bit of additional color, because what Philippe and Kai were mentioning quite nicely is this is not necessarily only about Kubernetes, right? So this is not about containerizing workloads. So we are using cloud native almost as a nickname for the desire to lower TCO overall with an end-to-end view, using principles that first started with cloud native deployments, i.e., where you are building an infrastructure that is self-healing, that can observe itself, that no longer requires you to go and look after individual functions as cattle, as pets, as we typically use, like this mental model, right? We're not using these things as pets anymore. We want to use them as cattle. So I think we're looking at a larger transformation that cloud native actually inspired, because it's built into Kubernetes. But sometimes I also find that this mental model of calling it cloud native transition is a little bit limiting, because we're looking at things end to end, and we're looking at an operational model that is not necessarily the same as the origin of Kubernetes workloads, right? Kubernetes workloads were built for front-end and back-end services, databases, hosting an API. Not so much for things that have multiple network interfaces and shift packets around, right? And do that at very high speeds. So maybe I think we need to go and enlarge the question a little bit to kind of how do we operate networks in a modern way, end to end, with new foundational principles that we can go and, well, all the way evolve to some autonomous level, TMF Forum 5 as the North Star maybe, but ultimately lowering TCO.
That's
And we've seen
that's
this through
an
projects, by the way, like OPNFE started with that,
Mhm.
AnuCat took over. All of them try to go and simplify the deployment of network functions. And well, Silva and Philippe is in the middle of that. I think it's the latest incarnation of these things. So open source is obviously complementing these efforts. And all of these projects have always zoomed out from just like, oh, it's container networking, right? So container networking is one very important piece, but it's not the only piece.
Thanks, Frank. I think another interesting point that you brought up there is this entire notion of pets and cattles. And I think one of the promises of cloud native is, you can have your network elements treated as, cattles, not pets. So where are we on this promise? Has it been delivered? Back to you, Kai and Philippe, in your experience and your deployments, is that the biggest promise that is driving these transformations for you?
So it's it's definitely something we're aiming for to get a holistic view and look at kind of the whole thing and manage it together rather than looking at individual things. We are not yet there. Yeah. So what the promise, I think, how I would describe the promise would be kind of, first of all, we are optimizing the operations aspect. So kind of the way we operate the network is more kind of operating in an IT environment rather than the networks and network elements we used to do. So the pads, right? So this will ultimately reducing the OpEx because we will have a more efficient way of operating things. And because also with the holistic view, we can see the influences from the one to the other. Then we also see that we accelerate the way we change the network and apply functions and to adapt the network to the user's needs. Finally improving also the user experience with that because we are becoming more flexible, we are becoming more agile in the way we operate the network, in the way we provide services to the end customers. That is at the end, it will be a different kind of experience by the user that they really get what they need in a real time rather than that we are working it on a static network and so on. So there's more to that than just that it's cloud native. There's also kind of driving network functions with APIs and so on. But the cloud nativeness will help also to accelerate that. Also, when we see in the 6G context, there is a lot of talking about combining network and the services together, smart networks and services, also a EU initiative to have these 3C networks, to bring kind of services and network closer together. And this is where we need to apply these changes because otherwise we are ending up in silos sitting side by side. So this is also the promise cloud nativeness will bring.
On my side, I fully agree with Kai. We are not done. It's a long journey, and we have very important milestone in front of us. So of course, Kai talked about the 6G, but I guess that when you are considering the different network master plan for operator, at least in Europe, 2027 and 28 will be a very, very important milestone. So it means that we are heavily investing in the cloud native area to be ready for the milestone of 2028 and 2030. So it's very important to keep this in mind. Something that could be perhaps interesting to I is to understand the why of the cloud native, because we are not the digital titans, or we are not the very famous, I would say, Netflix, Uber, and whatever. We do not need to ship new features every 20 seconds. The dynamicity of the functionality in our network is not at this stage. So it means that the reason and the core why is totally different than what we got perhaps in the IT, echoing the very good comment from Frank. The reason why is about end-to-end operational efficiency, because the principle of cloud native apply to build the infrastructure, to manage the deployment, to manage the operation, and even up to the orchestration if we have the right CRD and the right operators to be sure that we are able to operate the network function the right way. So the operational efficiency is a very, very strong reason. The second one, according to me, is the resiliency. The resiliency, the closed loop, the health management, the self-healing management, the drift management are core native to the cloud native design principle and runtime. And when you are in the telecom operator space, you are managing very critical and vital workspace, and you need the resilience. And the last one is because it's I would say microservices and container based, and it's only a small part of the full cloud native pictures. We have to keep in mind that is the highest compute density per hardware infrastructure. So it means that it could help also to manage the sustainability topic and very, very carefully managing the power usage based on the scale up and scale down according to the true usage. So yes, we are not done, but I think that we all agree to the reason why we are doing this. We can also perhaps very quickly break down the maturity level. And according to me, we have 3 stages. We got the infrastructure, we got the deployment lifecycle and operation, and we got the network function workload by themselves. According to what I'm currently observing at infrastructure level, I'm very impressed by how much telecom operators are able to bring very industrial grade deployment from bare metal to virtual spanning up to the edge. On the deployment and lifecycle management, GitOps is more and more on the forefront, and a lot of peers, and it's particular discussion and joint work we have with Deutsche Telekom in the Silva ecosystem around GitOps, and I think we are pushing forward, and the network reliability engineer start to point out at the next generation, I would say, job. The last point is really related to the network function workload by themselves. And honestly, here we have a very diverse level of maturity in terms of implementation. At the end of the day, it has no sense to build industrial, I would say, cloud native infrastructure if it's to run overbloated container containing the monolith we got in the past in the virtual machine, totally bloated into a container that will absolutely kill all the core property of the cloud native. So here is basically my voice complementing what Kai presented.
And maybe you want another echo, right? Because like we've seen very similar things across like what we started with OPNFV, which was mostly VM workloads. But even there, we saw the challenge that different things require different installers on different core infrastructure, and the qualification was always challenging. And we had certification programs throughout all the way to what we have in Anocat with or now as a standalone project with CNTI in the Linux Foundation Networking Consortium. So that problem kind of was always there and is always there of adapting network functions and qualifying these network functions on the underlying infrastructure and orchestrating them in a larger context always kind of requires some level of coordination. That said, and I think I want to echo what Philippe said, I think we are really into the journey. It's not that we are about to start the journey, but many carriers have started it and have successfully completed it, right? So I can go and mention a subsidiary of Deutsche Telekom, T-Mobile, who was really into the whole thing with cloud native cores and associated gateways. We've seen like gaming deployments like from Saudi Telecom, all cloud native, end-to-end orchestrated, end-to-end secured, and even end-to-end observed so that you can go and achieve closed loop end-to-end even. Like, so we've seen all these examples, but obviously I think we need to go and bring the entire industry along. And yeah, some of the people in the industry are a little bit further along. Some of the people are slower. I think that's just natural.
So I think you touched fairly upon some of the challenges, but in your perspective, Philippe and Kai, what exactly is, because when we hear or when we do some of the surveys, and we found this in the research, people would expect cloud native to grow to a certain level, and they and then they are comfortable with VNF based deployment. So what is it that's holding industry back? What are some of the challenges that you see? I think one which we discussed already is understanding or having this common understanding of cloud native. Apart from that, what other challenges would you like to describe?
I can start very quickly here. I think that on the challenges that we have in front of us and that we need to tackle in the full ecosystem, basically. For me, we got 5 that are very important. The first one is how can we ensure seamless integration and management of multiple network types. 4G, 5G, Wi-Fi, and it's echoing the multi-networking capabilities spotted out by Frank, and it's driving to perhaps having a more dynamicity in the way to choose the right CNI according to the use cases. It's something that honestly is not done according to me. The second one is on the resource optimization. I touch a word upon, but I think that we truly need a better efficient utilization of the compute, the storage, and the network resources. And here, tracking and optimizing would be very, very important. On the GitOps, I touch a word also on this one. Today, I think that we could go much further and reuniting, I would say, the infrastructure and the network function deployment much further. And it will certainly need a different approach in the way we are making today the orchestration of the network function by themselves and having implementation that are more closer to what we got into the cloud native space with operator, with CRDs, and using the orchestration and lifecycle management of the orchestrator. And the 2 last one that are also very important according to me is related to observability and to security. So yes, it's about integration of connectivity at large, resource optimization, full spec for GitOps, observability, and security. Definitively, it's for me a part of the big challenge we have in front of us to perhaps accelerate the speed on the cloud nativeness.
Yeah. Maybe to add to that, and maybe also to the point of that the NT space has some differences to what we have achieved in the IT space. Let's take the network requirements, hardware requirements, and so on. So there is a lot the NT would bring to the bill, and the yet today established cloud native kind of rules are not all kind of reflecting that in that space. So we need to work on that really to get it also developed into that, and maybe to break up some of the rules which are given in the early days of cloud nativeness, so that you are fully independent of hardware, which is not going to be fulfilled anyways anymore with when we start to use AI, because then we will also get some dependency on specific hardware features, and that is kind of also maybe helping us a level to improve kind of cloud nativeness also for the network workloads, because similar requirements, accelerators, network functions, a kind of high speed kind of transport and so on, will kind of also being requested by AI workloads. So there is something we can do. The other point, which is probably also hindering us, is someone told me once, oh, the NT world is turning so fast. You look 10 years, every 10 years is new mobile network generation. Come on. And this is slow. Every 10 years only. If it would be an IT application, that would be every 3 years, not every 10 years. So we wouldn't wait for 10 years to get the first digit rolling on an IT application. So that is, we are slow in this area. Our deployments are running long, and so kind of the innovation cycles are longer, so we cannot easily adopt what is on the market, and the suppliers are struggling because also it's a different business model there, and yeah, understanding what kind of dilemma they might be in, we still need to work together in order to solve the problem and to get there for not waiting for the next generation, but trying to get there as soon as possible.
Kai, this is a brilliant point, right? Because my boss calls this, we need to go and get to insane mode. And insane mode is pretty much what the industry is in if you look at how quickly AI is evolving and moving. This is no longer counting in even 3-year cycles, right? We're talking 3-day cycles sometimes when yet another breakthrough comes out. And I'm hoping, much like you, that AI might go and propel what we're doing here, even all the way down to like changing the Kubernetes model a little bit more quickly. So one thing that we all struggle with is like, yeah, historically, pods have a single interface. Like, it's not really what a network function typically looks like. And also, networking was never ever really built as a first-class citizen into containers. So you go into the kernel, have multiple copies of the packet until you finally reach the pod. That's obviously not efficient, and it takes a load of CPU cycles away. And that's to Philippe's point, right? There is hope there, right? So many people so far have been saying, okay, I need to go and map the interfaces directly with SRIOV. So that's kind of a kludge, because then you're losing all the benefits of moving the container around. So you're losing the cloud nativeness. But yeah, we have to do that. But SIG network, so the SIG multi-network, so the special interest group, has geared up to solve that problem finally for everybody, so that we don't really have solutions only like with Calico VPP, but they are broader. Maybe AI will indeed accelerate that movement, because AI has exactly the same needs. Like networking is a first-class citizen, right? Job completion time in AI depends on worst case tail latency, right? So it's network bound in many cases. And there is more people running AI workloads now than just NFVs. Yes, of course, right? Because that's like where everybody's going. So there's hope there. I also believe that there is hope in all the other fronts, Philippe, that you mentioned, right? Observability. I think the world is moving to OTel throughout, right? Open telemetry, open source, one of the largest initiatives that we have. Security, we're seeing that a load of the network functions start to rely on eBPF as an infrastructure to go and enforce security throughout, so that you have security in the fabric, as opposed to you need to go and build it into VNF. So there is a load of open source efforts complementing what has been mentioned earlier on, that I believe will propel the current journey and make us faster, so that we can go to, even in telecom, to insane mode.
Thank you, Frank. I think there's no discussion that goes without touching AI these days. And I guess what we are saying is there is some sort of parallels that we can draw between the compute or the stack requirements for NT workloads and AI workloads. So any comments on that, Philippe, from your perspective?
Yeah, a joke I'm very often giving is that if as a telco you are not sure the reason why you need to turn cloud native, and how do you pretend to manage your AI? Because what is super interesting is that the inference runtime stack that is currently at state of the art right now is perhaps at more than 80 or 90% the same that what we are running for the cloud native in the telco ecosystem. So it means that turning AI native for a telecom operator is certainly on the journey of most of us. And the true reason is mainly for operational efficiency and cost saving, and also and firstly for customer experience and network quality. So it means that the decision to manage those kind of workload at scale will rely on a very large commonality of what we are already building today. So to say it in another word, all the telecom operators who heavily started their cloud native transformation to run cloud native network function, I think are in a good momentum to extend their initial investment and work toward AI, because the stack will have a strong commonality, whether is it to run inference at very low level like VLLM, or at serverless side with model mesh. We got very interesting orchestration like Q to manage the orchestration and the deployment of the model. The way the GPU and hardware acceleration is abstracted is I would say very well advanced in the way Kubernetes is managing this. So there are a lot of commonality.
Thank you, Philippe. Any other comments before we open up to Q&A?
Well, maybe I zoom out a little bit, right? So one thing, and I think it was Philippe who mentioned that in the opening. One thing that is holding us back right now from getting really the thing done end to end is us, humans. So we managed to automate certain portions, and in many cases we have, say, if you follow TMF forum, we have level 3 automation in many cases, which is rule-based automation. But then it requires a human to take a decision, and then you move on a little bit, and then you require another human typically to take a decision. Even kind of if you troubleshoot, like you have certain people that are having insights from this domain and other domains, and you need to go and bring things together, right? So it's always a little bit of the system does something, and then you wait for a human, and then go back. Yeah, so that leads us to, can we remove the human? And the big promise in the market right now is if we do this using AI and agents. So that moves into this domain of agentic AI. And for us, it will not be an agentic AI that runs at one place, right? It will be an agentic AI that ropes together people, no longer people, but agents from multiple organizations, from multiple roles. And we started to go and call this the Internet of Agents, right? Because we suddenly have to go and interconnect agents and pieces of automation systems in order to go and get across that hurdle that you always require this human in the loop, and humans are slow and they need vacation and time off and weekends and all that stuff. So we're hoping that we can go and bring distributed agents together. And again, like this is a big movement in open source right now. There is agency.org, for instance. There's multiple efforts in this space that try to go and build this next generation where we can rope together individual systems of agents across the internet. And I think this has a load of promise. Again, tearing down barriers of what we see right now from an overall automation perspective.
So maybe to also add on that one. So we're going to use AI for kind of managing our networks then in the future. So using kind of all the agents, using all that. What is probably what I would emphasize on is that we need to put the effort of AI at the root of everything. Because at the moment we are looking at agents at the leaves of the tree, right? So we are doing a little bit AI here and a little bit there, but it needs
100%.
to be from the root. And there are leaves, and probably that needs to be managed. But the foundation is really in the root of the tree. And kind of this this path to that would mean that we are influencing the network with AI in a much faster way. And if we don't apply cloud nativeness now to that, what are the levers AI can use to change that, to have kind of a closed loop operations automations, closed loop automations with that, without kind of the abilities we need from cloud nativeness to really change things in a declarative and intent-based way. So it wouldn't work, right? So that is where kind of this links together.
Okay, Thank you, everyone. And let's just quickly look at some of the questions which were submitted. We just have 2 more minutes to close this panel. So I'll quickly pick a couple of them. Is there any correlation between Gen AI-based use cases and cloud-native tools? How operators are going to use the power of cloud-native architecture? I think we discussed it during the panel. Anything you would want to bring out?
Yeah, it's basically what I just said. So
Yeah.
we have kind of cloud native as a base in order to apply AI in order to make changes to the network and adopt.
Okay, another one. As DT and Orange evaluates its long-term cloud strategy, how are you approaching the potential transition away from legacy platforms?
I can jump on this one. The first thing is that today, when it's about legacy, it's about virtual machine orchestration. And we are already since, I don't know, 4 to 5 years already building the OpenStack deployment thanks to cloud native. So we don't not deploy OpenStack raw anymore. We are using cloud native ecosystem and Kubernetes for the high level of automation and so on. And then basically we could feel that it's working like I would say traditional VM ecosystem, but it's already cloud native to manage the upgrade and the different update. And here, what is very important regarding the legacy transition, we need to very deeply look at which kind of workloads we are talking, because when it's vital and critical, I think it's very challenging, but we have network functions that are more IT related. And for instance, we have KubeVirt technology that could perfectly fit and make running traditional VM already inside a cloud native, truly cloud native infrastructure as, I would say, a continuity before waiting for another maturity level. So I would say it's already in the map that we are managing.
Thank you, Philippe. And thank you, Kai, Frank, for this wonderful session. We are right on time, and